So this is the iCharger306B, which I purchased to balance, charge, discharge, and analyze my Nissan Leaf modules. This costs about $160. It was the cheapest model that did everything I wanted it to do at the speed I wanted it to do. They have more expensive models that have dual outputs. I only needed the one output. So you have your positive and minus output there. There's a temperature sensor. So in the box, when you buy it, you get this remote temperature sensor, so you can plug that in and monitor temperature in a battery pack. Also comes with the oldest style micro USB port for right there, so you can hook this thing into a computer, and there is some open source software called Data Explorer that lets you chart your battery as it's discharging or charging. It comes with these little clip-on power things with the banana jack connector inside. I'm not using those for the power input. I bought a separate cable that I've wired up with ring terminals to connect into a different Nissan Leaf battery bank. Power input here is pretty wide range. It's 4.5 to 38 volts DC. Normally you plug these into like a car battery for charging RC aircraft in the field. I'm actually quite impressed. It goes up to 38 volts. It goes down to 4.5, so you could plug this into a 6-volt golf cart battery or a 24 or 36 volt battery system if you wanted to. Now the only downside, of course, is it does not have an AC adapter, so if you wanted to run it off of AC, you're going to have to buy a power supply in that range that you run off of AC. It also comes with some output ports here that just clip on the batteries, but I had to make my own cable for the Nissan Leaf modules. Alright, so down here I have a group of 6 Nissan Leaf modules wired up with these 3 in parallel and these 3 in parallel and the whole set in series, so it's a total of 16 volts. And I have these guys wired into the ring terminals, so I can just plug my RC charger into that, and that powers it up. Also, because this is a battery, I can put power back into that battery when I'm discharging. I have one of these 6 modules hooked up for a balance charge or balance discharge. I have the negative connection to this black negative one. There's the sense terminal in the middle, and then positive connections to the positive side here. Now, right now, both halves of this module have basically the same voltage here, and this is the upper voltage I use, which is basically 4.15 volts, and in this case it's 4.142. And if you look at the other side, you can see here that's 4.13, so it's pretty darn close. It actually used to be 4.14, but apparently this side over here is going down just slightly, and that is the weak side in this particular module. So what I'm going to show you is how we use this iCharger to discharge this and determine how much power we get out of it before one of these 2 modules hits the cutoff voltage I've set. I'm going to use a 3.3 volt as a cutoff voltage. I'd go from 4.15 to 3.3 when testing each of these. The exact starting point and ending point isn't super critical. I use those voltages because that's kind of what I would use in normal usage. Some people test from 4.2, which is the absolute max, down to whatever the absolute minimum is to get just a couple more amp hours out. But generally, you're not getting too much more at the upper and lower end of things. Now, connections to the charger, we have our power leads, the plus and minus power leads. We also have this guy here, which has 3 connections. They come also from the plus and minus and the center sense terminal. So this little port here, when you plug that in, the system can measure the voltage on each of the different modules. And you might notice that when I did that, it automatically said, oh, you have a 2S battery plugged in because you have a 2S plug there. So it knows I have a 2-cell battery, 2 cells in series. Now I'm going to show you all of the settings I use for discharging here. So we're going to go into the settings and go through all of those, and I'll tell you which ones are important here. And there's a lot of different settings. So the safety timer I'm going to turn on for this particular procedure. And probably more important than the safety timer is the capacity cutoff. And this here is set at 50 amp hours. So these particular modules are probably closer to about 47 amp hours. They're rated at 60 amp hours brand new. I know they're not quite that good. If I ever hit this cutoff, I'll maybe go up to 55, but that's just a safety feature to say, hey, don't discharge more than 50 amp hours regardless of what the voltage level is. Now, the input limits here are more important for charging. I don't want my input battery to go below 15 volts, but there's also, for your discharging, I'm going to be using a regenerative discharge here. So regenerative discharge, it's turned on, and what that means is you have to be plugged into a battery for your power source that can have power put back into it. So don't put more than 30 amps into my battery, and don't raise my battery voltage above 16.5 volts. And so that's not going to be a problem for me because this battery is much bigger than the cell and the module I'm taking out of. But those are limits that you want to have set correctly for your particular battery. And that's all we need for the settings. Now, in the actual operation, we go to lithium battery, and we don't want balanced charge, or fast charge, or storage. We want the discharge. And with the discharge, you can set a max amperage, and you can set an ending voltage. And so I'm going to use, in this case, it's LiPo settings. And you can change, which setting it is, but that doesn't really matter too much. I'm going to use probably 20 amps here, just so it doesn't take too long and we don't hit the timer for the maximum amount of time to discharge it. So this should take less than 3 hours because if it's 60 amp hours we're taking out of it, that would take 3 hours. Now the ending voltage here, I'm going to take this to 3.3. So my ending voltage is going to be 3.3. And if either cell hits 3.3, that's when it ends. So you might have a case if one cell has more capacity than the other. One cell might hit 3.3 while the other cell is much higher. Okay, and so those are the settings I'm going to use. You just long press the start button. And because we're doing a regenerative discharge, it says, hey, you're putting battery power back into your input source, confirm, and so hit start to confirm that. And so off it goes. You can see it's slowly ramping up the amp draw, just to, I guess, give you a chance to detect if something's going wrong. But there it's up to 20 amps. And the fan comes on, because even though it's putting most of that power back into the main battery, just the switching losses are causing some heat loss. So at some point I am going to have to charge my input battery after doing this a lot, but by charging and discharging to and from it, I'm saving a little bit of power. And you can watch here, hey look, that cell over there is dropped to 3.91 volts, so it's sagging quite a bit, whereas this cell over here is at 4.11 volts, so a very minimal sag, 4.10. So this is the weak cell. That's the one that my BMS had drawn down to 0 at one point, and so I'm expecting the capacity on this entire module to be limited by that cell. So when that cell reaches 3.3, we'll know what the entire module's capacity is, and we already know that that's the weak cell. So we let this thing run and check on it when it beeps at us. So after it's been running for maybe 4 or 5 minutes, you want to do just a finger check. Check for warmth on all of your connections, and you can check your wires too, although usually it's the connections that are going to get you. So I also check, the connections on my input battery, and more importantly, the connections that I've just screwed into on the top of the module, just to make sure they're not getting uncomfortably warm. A little bit of warmth is expected when you're dropping 20 amps through a wire, but if there's any doubt about, if you can't keep your finger on it for a long period of time, that's probably warmer than it should be, and you can reduce the amp draw if you need to. So I do like the ability on this particular setup, if you press and hold the start button, the amp draw starts flashing, and you can say, hey, I want to go down to 15 amps, or hey, this is taking too long, I want to bump it up from 15 amps, up to 20 amps. And so you can change the amp draw while it's running. with lots of beeping, and then press the start button to get the new amp draw. So that is adjustable as you're discharging the battery. Alright, so that got done a lot faster than I was expecting because one of my cells is definitely low. So 46 minutes, it did 15, almost 16 amp hours, terminated because a cell voltage was, or a cell was low. So this guy's at 399, that's at 374, so the one I thought was low must have dipped down to 3.3, and then it looks like it's bounced back up once the current draw was off. Let us hit this thing again. Confirm, yes, we're putting things back in the battery. And we're going to watch that thing. So yeah, it's down to 3.59. So at the 20 amp draw, this cell over here is definitely sagging. So that module has significantly reduced capacity compared to the good modules. About 16 amp hours on the worst cell. Now the good cell over here could probably go quite a bit longer, but they're really only useful as the weakest cell in the module, unless you want to take the module apart and repackage it somehow, or only use half of a module, which might be useful for a 12-volt battery.